Welcome to the Laboratory, a video series brought to you by Miracles Innovation Labs.
Hi everybody, welcome back to the Laboratory video series brought to you by Miracles Innovation Labs. This is Aditya Chinni, and I'm going to talk a bit about fruit detection using Microsoft Custom Vision on a Raspberry Pi, and how beneficial is having your machine learning models running on your edge devices like Raspberry Pi. Let's move on to the agenda. So today's agenda would be why ML on edge. I'm going to talk about why machine learning is slowly moving on to the edge device and what the advantages of moving that onto the edge device. A bit about introduction about how custom vision is helping us in terms of training your models and then bringing your model onto your edge. Edge devices, couple of edge devices like CPUs, TPUs, and GPUs, like how slowly CPUs, TPUs, and GPUs are coming into the market. Tensorflow Lite and OpenCV frameworks, like how these are helping us in terms of having your applications running and getting the things onto your edge devices. Then comes the solution architecture. Like I'm going to explain about what we have built with the fruit detection demo, and right after that I'm going to take a live demo for you so that you can actually see and enjoy and learn about what we have done at Miracles Innovation Labs. So before going into the actual slides, I want to talk about Miracles Innovation Labs. So we are people of like 100+ researchers working on really cool technologies like Internet of Things, cognitive computing, next-gen, cloud computing, machine learning, and others. And we do have a RIPS process where we take challenges from our customers in order to build an end-to-end solution on these technologies. We also have a co-innovation model for pilots. That's where we work and deliver things to customers back. And we have our laboratory video series at miraclesoft.com/thelabs, where we've been posting our laboratory videos from across all the technologies that we have, and like there are already 50+ videos on the YouTube, and you can go and watch those videos and learn something from us. Edge computing and why the intelligence is moving slowly towards edge. So everybody are talking about edge computing, and so what's edge computing and what's the advantage of that? So basically, whenever you build a machine learning model, you have your model running on your cloud servers, which is like very high-end powerful and high-end processing. So that's where it takes a lot of amount and time and a lot of cost in terms of getting your models running properly. But when coming to edge computing, you can actually have your model running on your locally on your edge device, and you can process and get the data really quick. And machine learning models can run on the edge devices because it provides significantly faster predictions for critical IoT applications as well. Processing and analyzing data like images or videos will be really quick on your edge devices, because that doesn't rely on your network, because whenever you put your whenever you put your machine learning models, they're going to run on your edge devices. So that's where you don't really need a network or a bandwidth to actually go and get those model results from that. So that's where it gives you a faster analysis and faster processing of your data, and it also reduces data privacy risks as well. So that's where you can see the right side image where the trained models are then converted into Tensorflow Lite converters, so that they can actually have deployed onto your edge device like phone or Raspberry Pi, your smartphone, or maybe an Intel Edition or any other devices that we have right now in the market. Why ML on edge is really important, because we have to understand what the advantages of having your machine learning model running on the edge devices. So basically, whenever we develop machine learning applications, we have your machine learning model trained on some other tool. Maybe at this point of time we've been using Custom Vision from Microsoft, but we have a lot of other tools that are already there. So when you develop your trained model, you actually host it on a cloud to actually access that from your application. So that's where like it takes a lot of time in terms of processing your data, because it has to go back to your vendor-specific cloud and then have a proper bandwidth in order to get these requests back. So, but if you have your machine learning model running on your edge devices, like somewhat like Raspberry Pi or other Odroid devices, so what it actually happens is the main advantage would be the processing of data locally would be really, really fast, because your model is running on the device right now. The better application speed, where your application will be processing very quick in order to getting your request and putting it on your dashboards. That will be really speed, and it increases security for the devices and the data that's flowing in and out. And really important thing that for the enterprise or the CEOs, the CDOs would be it lowers the cost, and then the lower network traffic, because the entire machine learning model which is running on your edge doesn't reside on any other network, because it's running right now on locally on your device. So it really doesn't care about the network that you want to have. And faster real-time predictions, that's really important for a kind of IoT applications right now. So coming to Custom Vision, so Custom Vision is a service from Microsoft. Microsoft is having a cognitive service that's called Custom Vision, and Microsoft is helping us to actually train your images and then evaluate that by taking those images results from the dashboard itself. So they have SDKs as well, so you guys can actually go and try and play with those. You can actually upload images through the dashboard and then train it, and then have your model coming down. You can actually download the model and then host it on your edge devices and start programming using TensorFlow and OpenCV in order to access these models. So they are actually providing a fast way to build, deploy, and improve an image classifier. So you can see on the screen like how the flow is going on. You can upload and then train and then evaluate your models as well. So that's all about Custom Vision. It's a free service from Microsoft. You can actually go and try. Coming to edge devices, so edge devices are slowly moving from CPUs to GPUs and then TPUs. So slowly they're getting smarter, because whenever you're trying to play with your machine learning applications, you really need a really fast processing power and multiple cores in order to get your machine learning model executed or processed. So that's where initially we used to work with CPUs, which is like minimum cores and get optimized. Whenever you have your application running on CPU, it really takes multiple amount of days or even weeks to get your machine learning model to be processed. So that's where there comes the GPUs, with like thousands of smaller efficient cores helping us run the machine learning model in a multiple threads, so that the processing of data would be much faster when compared to a CPU. So it reduces from days to even like hours. So that's where like GPUs are coming up very fast in the market right now. And there's a new thing coming up from Google. It's like TPU, the Tensor Processing Unit. We've been waiting for this. Google announced in the last conference, but still they say that this is improved 10x compared to your GPUs, because this is mainly important for processing your model than getting your model trained. So we have to wait and see like how GPUs are going to work right now once they're in the market. So TensorFlow Lite or TensorFlow or OpenCV, these are all like the frameworks or the libraries that we've been using for developing our machine learning applications. So your application framework would be mainly depending upon like OpenCV and TensorFlow Lite, so that these embedded devices can actually process these things, get your models executed fast. Architecture, fruit detection using ML on edge. So this is basically like, let me explain, because I want to have a deep understanding about this. So we have these fruits like apple, pineapple, or orange, and other fruits. We've been training these using Custom Vision on the left-hand side, you can see, and then testing that for the evaluation, and then that gives you the accuracy as well. So whenever the model is running on the edge, so we've been getting this edge model deployed onto the edge device, which is having TensorFlow and OpenCV running on that, so that it actually processes your model and then puts into this Azure IoT Hub for a new model that's available. So so we have this blob storage that we're using. So in order to have this blob, whenever the new trained model is ready available, it's gonna store that in the blob storage, and there's an Azure function that's triggering us, saying that hey, that there's a new model available in the blob storage, so that our edge device can actually give a call and take that model down onto your edge and then process it locally. And whenever you show the right image, like whenever you show the apple or banana or whatever the image that you want, whenever you show it to a camera, it actually detects and puts on the 8x8 LED matrix that we have on a Raspberry Pi. So I'm going to show that in the next live demo, so you actually can see how the fruit is actually detecting whenever we show it to the webcam that's there in the demo. So with that being said, let's quickly move on to the live demo. Okay, let's quickly jump onto a quick demo that we're talking about. As I mentioned previously, like we're using custom vision in terms of training our model, right? So if you can see on the screen, you have a couple of fruits over there. It's just toys over there. They are not real fruits. So we have pineapple, orange, and apple. Basically we've trained these fruit images to a machine learning model using custom vision service. So once the model is there, so we are trying to bring that model down onto your edge network, and that model is right now running on the edge network. And if you can see the Raspberry Pi with the LED lights, there's already a Apple identified. So previously we just tested, and the Apple got already identified, and the LEDs glows in a red color. States like an Apple symbol, but it's not that accurate. So let's quickly showcase the other things, how they're going to work. I'm going to showcase the pineapple to the camera over there. So once the pineapple image, like pineapple fruit, is showcased to the fruit camera, so you can see on the screen that red color has turned into a pineapple symbol with the green LEDs glowing on. That represent like whenever we are putting a fruit in front of the camera, the entire frames are actually being sending to your machine learning model to identify whether the product or the fruit that is there in the frame is identified, and it shows the result over there. Let's go and test again with Apple. So obviously it should show us as a red LEDs. Yeah, there you go. Now it turned into Apple, and it says like it's identified as an apple with an accuracy of 99%. I cannot show you the logs. It's running on the edge device. But the accuracy is 99% over here. And let's go with the orange, and this should be a slight different when compared to pineapple. So the lights seems to be similar, but the log says that it's actually orange. So we don't have other things to identify the orange as orange, but those lights are really orange in terms of getting that done. So with that being said, thank you. Have a great day.
Thank you for watching The Laboratory, a video series brought to you by Miracles Innovation Labs. For more on innovation, please visit miraclesoft.com/thelabs.